So here are the notes for Chapter 0.5, Section 3. What we're going to do is we're going to solve systems of linear equations using matrices. So in this case, we're going to be using our graphing calculator and using matrices to solve linear equations. So what we're also going to introduce is when we have three variables. So a linear equation is a graph or is a plane in space when we have x, y, and z axes. Now, linear equation in three variables is as so. So we have ax plus by plus zz equals d. And when we find a solution, so basically a point, it's going to be an ordered triple. So we're going to have an x, y, and z value. So just like we've learned when we have two variables, it is possible to have with, in this case, a point, one solution. This is when we have the intersection of three planes, and they intersect at one point. Now, if our three planes intersect in one line, then we have infinitely many solutions. However, if those planes never intersect, so they're parallel, or only two out of the three planes intersect, then we have no solution. There's no points that they have all in common. Okay, so let's go ahead and talk about what is a matrix. So it says here, a matrix is a rectangular arrangement of numbers in rows and columns. The dimensions of a matrix are the number of rows by the number of columns. Well, let me show you an example of this. So basically, we will have like brackets to use. And let's say I have the numbers 1, 2, and 3. So going horizontally, these are what we call our rows. And then going vertically, that's what we call the columns. So we look at this matrix, we can definitely see the number of rows and the number of columns. So when we talk about the dimension, we say, in this case, we have two rows, so we have 2, and then we have 2 columns. So we have a 2 by 2. That's the dimension of this. Let's say for our next example, we have this matrix. So we have 5 and 6 within our matrix. Now notice here, once again, we have 2 rows, but we only have 1 column. So when we find the dimension of this matrix, we go by rows first. So we say 2. The x represents the word by, and then the column we only have 1. So the dimension of this matrix is 2 by 1. Okay, so now matrices with the same dimensions can be added and subtracted. And some matrices may be multiplied if the number of columns in the first matrix equals the number of rows in the second matrix. Now, you guys won't be learning about adding and subtracting, but we will be doing some multiplication here with our matrices. Now, we're not going to be doing that by hand. In fact, we're going to allow the graphing calculator to do that for us. Now, we can write a linear system as a matrix equation. AX equals B. Now, the A matrix is the coefficient, the X matrix is the variables, and B is the matrix of constants. So for our very first example, we're going to write the system of linear equations as a matrix equation. Then we're going to figure out the dimensions of our A matrix and B. Lastly, we're going to use keystrokes on our graphing calculator to find the solution. Okay, first let's set up our matrix equation. Now remember, we always have AX equals B. So we need to determine our A matrix, the X matrix, and the B. Let's start off with the A matrix. Now the A matrix consists of the coefficients. So in this case, remember, coefficients are numbers in front of our variables. If we look at our very first equation, negative 3x plus 4y equals 5, the coefficients here are negative 3 and 4. Now let's look at our second equation. In that case, the coefficients are 2 and negative 1. Now our X matrix is just dealing with the variables. Notice here that we're using X and Y as our variables. Then we set it equal to our B matrix. Now the B are the constants, so basically the numbers without the variables. Notice we have 5 and -10. Now if we look at the numbers on the first row, -3, 4, and 5, all those values come from our very first equation. While our second row, 2, -1, -10, that comes from our second equation. So those should be corresponding. So now what we're going to do is we're actually going to plug the A and the B matrix into our graphing calculator so we can solve. So here's saying if AX equals B represents a system of linear equations, then what we can do to find the exactly one solution is actually, to solve for X, is move A over. Now in this case, when we do matrices, we never divide. We can only add, subtract, and multiply. So to move the A matrix to the other side so we can solve for the variables, we're actually going to take the inverse of our A matrix. And you'll see what that looks like when we plug it into the calculator. So now, when we plug in our matrices in the calculator, if you need to pause the video at any time so you can try this with your graphing calculator, make sure you do that. Okay, first thing here is we need to make sure we get our calculator to the main screen. If you're on something else, don't forget you can always press second and then mode to get to the main screen. So what we're going to do is figure out how to plug our A matrix in. So what we're going to do is press the second blue button, and we're going to go down the same column here where it says x to the negative first. Now that doesn't really represent an exponent. What it represents is the inverse. But notice above it, it says matrix in blue. Anytime you press the second blue button, it basically comes up with whatever the blue words are. So we're going to press this x to the negative first, or the inverse key, and it takes us to our matrix. Now in this case, we want to edit our matrix, so we are going to right arrow over to edit. Notice that we're going to edit our A matrix. So to do that, we're going to press enter. Now what we need to do is decide what is the dimension of our A matrix. Well, let's go back to this problem here. Remember, to figure out the dimensions, we do the number of rows by the number of columns. Notice that we have 2 rows and we have 2 columns. So we have a 2 by 2. So what I'm going to do is I'm going to press the number 2, then enter, and then press the number 2 again and enter. So basically it changes your box or your windows. Now we need to put in the values into our matrix here. So we're going to put in -3 first, because notice that that's the first box here. So we do -3, then we press enter. And so it's going to shift now to the right hand side. So now we put 4, enter, then 2, enter, and -1. So basically, I'm taking my A matrix, the numbers that are in it, and just putting it into the calculator. So now we need to do the same thing for our B matrix. So I'm going to move over. Let's see if we can figure this out. There we go. So our B matrix consists of 5 and -10. So in order to edit our B matrix, once again, I'm going to do second and then x to the negative first, or the inverse key. I'm going to right arrow over to edit, and I need to down arrow to number 2, where I'm going to edit my B matrix. I press enter. Now once again, let's go back to our problem to see what is the dimension of our B matrix. Notice we have 2 rows, but we only have 1 column. So we have a 2 by 1. So I'm going to press 2, enter, and then 1, enter. From here, we need to input the numbers. Going back to our problem, we said our numbers are 5 and negative 10. So I press 5, enter, and then negative 10, enter. Okay, now what I have to do is solve my matrix equation. So I have AX equals B, but the idea is that I'm trying to solve for my variable matrix, or the X. To do this, I'm going to have X equals A inverse times our B matrix. So now what we're going to do on our calculator is we're going to press the second and then the mode button. So notice that says quit in blue up here. That means you go to the main screen. Once again, we're going to do second, the inverse key. And now we want our matrices. So where it says names, basically where it takes us, we want the A. So I'm going to press enter. Now I want the inverse, so all we got to do is press the inverse key. Our next thing is, once again, I'm going to go to second inverse, scroll down to B, so make sure it's nice and highlighted, and press enter. So now I have A inverse of B, and I can calculate. So now I just press enter. And here, it basically gives our solution. So this is going to be where the two lines intersect. They intersect at -7, -4. So we have X equals -7 and -4. Now make sure you note, when we put our variable matrix, X was on top, Y was on the bottom. So our solution here is -7 is the X value, -4 is the Y. Now we do need to make sure that we write our final answer as an ordered pair. So I'm going to write -7, comma, -4. And that'll be my solution. Okay, let's go ahead and try another one. But now we're going to try it where we have 3 variables. Okay? So we are going to make sure we create our matrices, plug it into the calculator, and find our solution. So remember, the equation is AX equals B. So we have our A matrix. Remember, the A matrix consists of the coefficients. So we look at our first equation of X plus Y minus 3Z equals -17. The coefficients here are 1, 1, and -3. Now let's look at our second equation. Now be careful here, because we do have a 2 for the X, but we don't have a Y. So since we don't have a Y, we need to use 0 as our placement. And then Z is just going to be 1. For my third, we're going to have -7, -2, and 1. Now notice all the X values, they align, the Y values, and the Z values. Okay, now we have our variable matrix, which is our X. And our variables, as we can see, is X, Y, and Z. So I just put X, Y, and Z. Then equals our B matrix. Remember, the B matrix is just the constants, so those are the values without the variables. So we have -17, 12, and -11. So now what we're going to do is we're going to place our A and our B matrix into the graphing calculator. Now let's make note of what the dimensions are. So the dimensions of matrix A, we have 3 rows as well as 3 columns. So we have a 3 by 3. While for our other one, our dimension for matrix B, we do have 3 rows, but just 1 column. Okay, let's go ahead. We're going to plug this into our graphing calculator. Now, once again, if I am going too fast, make sure you pause the video so you can try to do these strokes on your graphing calculator as well. Okay, so what we need to do is we need to go to second inverse key, or the matrix key. Once again, we need to edit. So So we right arrow all the way to edit for A and B matrices. I press enter. Now I need to change my dimensions, so I press 3, enter, 3, enter, because we have a 3 by 3. Now I'm going to place the numbers that I have here. So I start off with 1 and press enter and do it again, and then I have -3. So every single time you press a number, make sure you press enter right afterwards. Then I have 2, 0, and 1. And lastly, -7, -2, and 1. Now that I have edited my A matrix, I'm now going to edit my B matrix. So once again, I go to second, the inverse key. I scroll over to the right or arrow over right, and I go down to my B, press enter. And then here, I'm going to have a 3 by 1. So I'm going to have 3, enter, 1, enter. So going back, we know we have -17, 12, and -11. So -17, 12, and -11. Just double check that's right. Yep. Okay, now we need to do second mode. And basically what we have to do is, because we are solving for the X matrix, we're going to do A inverse times B. So we go to second inverse. All we have to do is press enter because we want our A matrix, and then press the inverse key. And then once again, we're going to do second inverse, scroll down to B, and press enter. From here, we press enter one more time, and then it gives us our solutions. Now notice we are going to have an ordered triple because we have 3 answers, because we have X, Y, and Z. So here we have X equals 3, -2, and 6. But we do need to make sure we write our answer as an ordered pair. So we're going to write it as 3 because that's the X value. The corresponding Y is -2, and the Z is 6. Okay, so we do have one more problem to do on the notes here. And it is a word problem. Okay, so here it says Tracy wants to buy some pies for her sisters, and she has a budget of $82. And she's going to spend it on apple pies that cost $5, banana pies that cost $4.50, and chocolate pies that cost $5.50. Now, she wants to buy 16 pies for her sisters, and she needs to buy as many chocolate pies as apple and banana combined. Now, we're going to figure out, using our graphing calculator and using matrices, how many of each item she should buy. Now, the very first thing you should do with these type of problems is always identify your variables. So notice that we have apple, banana, and chocolate. So I'm going to use A for apple. Then I'm going to use B for our banana. And then lastly, C for chocolate. Now notice that here that we have 3 variables. Now this is going to be nice, so make sure you have this down. The number of variables tell you how many equations we're going to have. So because we have 3 variables, we're going to have 3 equations. So to figure out our first equation, let's look at the money. So she can only spend a total of $82. And notice that they gave us the price for each of the pies. So what we're going to do is we're going to take that price and set it equal to our 82. So we have 5 times A, so for every apple it's $5, plus $4.50 for the bananas, And then lastly, 550 for the chocolate. And then we're going to set that equal to 82. Now let's talk about the total amount of pie she's going to buy. So she says she's getting 16. So if we actually just add up all the type of pies we have, so A plus B plus C, that should give us a total of 16. Lastly, they talk about that she's buying as many chocolate pies as banana and apple combined. So when we write this, we know that if we do A plus B, it should equal our C. So now, using this information, we are going to create our matrices. Now, before we do this, let's look back at our last equation, A plus B equals C. Now remember, when we create our matrices, the B matrix can only have constants. That means we can only have numbers that have no variables. Notice that we have this C over here. So in order to have a constant, we do need to move the C over. So we do that by subtracting. So now we have A plus B minus C, because we subtracted it, equals 0. So now that I have a constant, I can create my matrices correctly. Okay, let's talk about the A matrix. Remember, the A matrix is with your coefficients. So if we look at our first equation, our coefficients are 5, 4.5, and 5.5. Our next equation, we just have 1, 1, and 1. And then for our last equation, we have 1, 1, and negative 1. Notice all the A's line up, the B's, and the C's. So now we have our variable. So remember, we used A, B, and C. And that's equal to our B matrix, which is the constants. In this case, we have 82, 16, and 0. And our equation that we're trying to solve for is AX equals B. Okay, so now we're going to plug this stuff into our graphing calculator. Notice that for A, we do have a 3 by 3. That's our dimensions. And then for the B, we have a 3 by 1. Now, if you want to, go ahead and pause this video and try to plug these values into the graphing calculator using your keystrokes. If you don't have a graphing calculator, then you're just going to follow along with what we're doing. Okay, let's go ahead and plug these into our graphing calculator. So once again, I have to go to second inverse. I go over to edit and press enter. And once here, we already have a 3 by 3, so I can just press enter. So I'm going to put 5, enter, 4.5, and 5.5. Make sure after each number you press enter. Then we just do ones all along this next row. And then on the bottom we have positive ones and then a negative 1. Now we do the same thing for our B matrix. We go down, make sure you go over to edit first, and then we go down to the B matrix. Since it's already on 3 by 1, I can just press enter. But we do need to change this, so we need to do 82. 16, and then 0. Okay, so now we do our equation. I go now to second mode, so it can go back to the main screen. And I'm going to do second inverse. I want my A matrix first, and then I do the inverse key. Then I do second inverse, scroll down to my B, and press. Once I've done that, then I press enter. And I get these values. So I have 4, 4, and 8. So we have x equals A inverse times B, in which x equals 4, 4, and 8. Now, usually we would write this as an ordered triple, but because this is a word problem, we actually want to create meaning for these numbers. So in this case, this means that we bought 4 apple pies, 4 banana pies, and 8 chocolate. And we got these values because remember, A was on top, B was in the middle, and C was on bottom. So this would be your final answer. So make sure for word problems you actually talk about what do those numbers mean. Okay, so if you have any questions on this, make sure you email me or come in before or after school. Definitely just keep working on these just to gain those calculator skills. And make sure you work on the homework. Make sure to show the work you create, set up the matrices, and then you can just plug these values into the graphing calculator.